Salaries in top tech jobs are crossing $1 million mark, and people still keep asking me, where's the compensation actually going inside the big tech today? See, if you sit inside large engineering organizations, you notice something important. Companies haven't stopped paying strong packages. They haven't stopped hiring specialists. They haven't stopped rewarding engineers. But the way value flows inside tech has shifted. Quietly, steadily, based on real business pressures. Hi, my name is Vinay Bansal. I've been working as senior engineering manager at top tech companies. So I can tell you firsthand what kinds of roles consistently land the top compensation packages. And in this video, I'm going to break them down for you. Not a generic Google search list, not vague advice like learn AI, and not unrealistic work hard and good things will happen. Instead, I'll show you the roles getting the highest pay today, why companies pay them so much, and how you can start positioning yourself to get there. By the end, you'll know exactly what direction to aim for if you want to move towards the top tier of tech compensation. So let's get started. The first highest paid role would be of staff software engineer or system architect. See, I know AI can write code, but software engineering still remains the highest paid job field even today. When people think high paying tech job, they often imagine someone sitting and typing code really fast. But the engineers making the biggest impact today write surprisingly little code themselves. See, at senior levels, compensation is tied to leverage. How much does the work you do protect, enable, or multiply value across the system? A staff or principal level engineer may define system boundaries, design multi-team infrastructure, prevent failures before a code is written, identify architectural risk, and cost sinks. Companies pay huge amount here because a single architecture decision affects hundreds of engineers and millions of users. Writing code solves one problem. Designing system prevents thousands. The good news is that you don't need to wait for years to develop these skills. Here's how to start now. Volunteer to review design docs. Map how data flows across systems, not just your component. Ask questions about failure modes and trade-offs. Think in cost plus scale terms, not just time estimates. If you can demonstrate system thinking, your career grows exponentially faster than those who stay in ticket execution mode. Second role is Site Reliability Engineer or the SRE. This role used to be a niche, but now it's core to business survival. Why? Because modern software never rests. System runs non-stop across continuous load across global infrastructure. And downtime is brutally expensive. If a payment system drops for a few minutes, that's millions gone instantly. If an AI workload overuses cloud compute, that's millions burnt invisibly. SREs are paid because they keep systems available, scalable, and efficient. Inside compensation reviews, the reasoning sounds like this. Their improvements reduce incident frequency by 40%. Their optimization saved us millions in cloud spend. The redesign removed the bottleneck, slowing the product launches. SRE isn't fixing bugs, it's protecting revenue and reputation. So if you're an engineer looking to break into this, learn observability tools, participate in incident retros, study distributed system fundamentals, take ownership in reliability conversations. Once you prove you understand system risk, you become invaluable. Next role is security engineer or security architect. This role is exploding in value. Why? Because breaches cost companies more than hardware failures. Security incidents can destroy customer trust overnight. Modern systems are deeply interconnected. A vulnerability in one microservice can cascade into multiple systems compromises. With the evolution of quantum computing, old security practices are soon becoming obsolete. Security engineers now work upstream in development process. They review architecture, validate boundary assumptions, design authentication and authorization policies, anticipate unforeseen risks. These engineers get paid extremely well because they prevent catastrophic losses. So if you want to step towards this path, learn threat modeling basics, understand zero trust concepts, study secure software design principles, participate in internal audits, Security thinking changes how you see code and systems, and companies want that mindset desperately today. Next role is one of my favorites, robotics engineer. This is one of the most exciting and lucrative areas right now. Robots are not future but are present. Look around, automation is everywhere. Warehouse robots, autonomous delivery, AI assisted manufacturing, medical robots. The bottleneck? There are very few engineers who understand both software systems and physical constraints. Robotics reliability problems are expensive. If a payment system fails, a transaction errors out. If a robot fails in a warehouse, production halts. Inventory piles up, contracts are breached. That financial impact is massive. So companies aggressively invest in engineers who can build reliable, safe automation systems. If you want to enter this path, you can learn control system basics, understand real-time constraints, build small robotics experiment, study how sensors feed into software loops. You don't need a robotics background to start. You just need curiosity about how software interact with real world. Next one is also very important. It is technical product or program leadership role. Let me clarify something important. These aren't management roles. I'm talking about technical product manager, technical program manager, platform strategy roles. These roles consistently land strong compensation packages because they prevent the most expensive mistake a company can make, building the wrong thing. Here's how leaders justify comp at this level. They aligned the product direction with platform constraints. They prevented waste in engineering cycles. They identified cross-team risk early. These roles reward people who understand customer needs, system constraints, engineering trade-offs, and business value. Engineers transition into these roles successfully when they start asking why, not just how. If you want to aim for this path, you should learn to map decisions to user value, quantify system cost impact, challenge ambiguous requirements, develop cross-team communication. You become the person who protects engineering capacity. This is extremely valuable. There's one more category worth mentioning because compensation momentum is gaining here. Engineers who operate at the intersection of cloud workloads, accelerated compute, early quantum experimentation. Quantum isn't mainstream, but companies are already experimenting with hybrid compute models. Engineers who understand architecture and system integration have become early experts, and early experts are always rewarded disproportionately. Start simple. Explore hybrid algorithm concepts. Learn workload partitioning ideas. Understand why quantum fits certain optimization domain. No need to become a physicist, just understanding the architecture integration is valuable. Now that you know the roles, here's the roadmap to get into them. First step is to shift from task to responsibility. Ask yourself, what breaks if this assumption fails? What system does this decision affect? What long-term cost does this introduce? Then look for failure paths, study outages, read root cause analysis docs, join incident reviews voluntarily, develop cross-team awareness, map dependencies, learn the broader platform, understand who consumes your work, communicate in business terms. Executors don't care about code, they care about operational risk, cost, scalability, customer trust. If you speak that language, your influence grows immediately. The highest paying roles in tech today are not about being the smartest coder. They are about owning systems, reliability, risk, cost, and impact at scale. If you want to move into these roles, you don't need a title change tomorrow. Start demonstrating these responsibilities today because compensation follows responsibility. It always has. And in 2026, that truth is stronger than ever. If you found this valuable, subscribe to BeTopTen. I'll keep sharing more such insights.